Hello everyone, I hope you guys can hear me. Okay, so it seems that people are still joining us, so let's wait for a few more minutes, shall we? Good evening everyone, welcome to Getting Started with Docker, organized by the FOSS Lanka community, alongside Mozilla LK and Women in FOSS community. And first of all, I would like to warmly welcome our speaker for the evening, Mr. Ravindu Fernando, who is an Associate Technical Lead at Immortal Inc. And before we start the session, we have an announcement for all the participants. At the very end of this session, we will be holding a little quiz where all of the attendees can actively participate. And also, you get a chance to win gifts. So I really hope that all of you will stay with us till the end. And without further ado, I cordially invite our speaker, Mr. Ravindu Fernando, to conduct the session. It's over to you, Aye.
Yeah, thank you very much. Just give me a moment to share my screen. Can you hear me?
Yes, we can hear
we can hear you.
Yeah, thank you very much. Okay. All right. Just give me a moment. Can you see my screen?
Yes, no issue.
Yeah, you can see. Yeah. All right. So let's start. Okay. So before starting, can I just know out of the audience? I mean, you can use the chat box and let me know. I mean, if you have used Docker before, you have any experience I mean, using Docker or any other, I mean, in general about containers or Docker? Have you used it before? All right. So let me see. That beginner. All right. Some they have used. Great. So I will be like our main motive was to kind of give an introduction to Docker. But then yet again, since some people have used it, so I will try to, I mean, align this session so that everyone who participates gets something to get away with, I mean, something to learn from this session. All right. So yeah, nothing about this. So you have already, thanks for the introduction, introduce myself. So let's straightly dive into the agenda for the day. So first we will be talking about like, brief history. I mean, we will be like, in summary, talking about infrastructure shifts over the decades. Um, then we will be kind of talking about virtual machines versus containers. And then we will be talking about what are containers and what problem does it solve. Then we are going to talk about, what is Docker. And then we will deep dive into Docker internals. And then finally, the demo session. All right. So brief history of infrastructure shifts. I wanted to put this because before we are going to talk about containers, so a technology which is enabling containers like Docker, we have to understand why we are here and why we are talking about this, right? So if we kind of recap major infrastructure shifts over the, I mean, years, if we go to like 80s, 90s, it was this mainframes to personal computers, right? So PCs come in with this distributed architecture, and then, overall changing of the networks, fiber optics coming in, and TCP, IP, everything. So that shift was the mainframes to PC. And then, it took like a lot of time for that shift to, I mean, become a thing. And then it was this bare metal to virtual, right? Because servers were too powerful and they had a lot of idle time. And, I mean, people wanted to find out like better ways to utilize that idle time. And the thing was virtualization, right? So lots of operating systems within the single piece of hardware, machine level isolation. And I mean, those are like defaults. Still to this date, we are using these personal computers, virtualization in some sort of the other. I mean, then it around 2010s, actually in 2006, 7, AWS started with this cloud thing. And, this idea of shift force data center to cloud, because this idea of easy, cheap, disposable computer power, just via an internet connection. And I mean, nowadays, everyone is using cloud in some form. And now we are kind of, in this host to container kind of shift. People have already done, I mean, some people are on the journey of moving that. Now it has become like, the standard way of compute object is the container, right? So this, you may have heard of this like serverless, right? If you take AWS Lambda, like likewise serverless things where you like, these functions as a service, where all those came into the scene because if you take serverless functions as service, underneath they are running within containers, right? So we kind of are, I mean, already at the levels where this is like the default way to run our apps. And the other thing to note here is this final infrastructure shift host to containers. This has been like, compared to other shifts, this migration waves has been happening really fast, right? So that's why we are in this position and we are talking about containers. And as beginners, you want to understand a lot of companies are using this. And if you, I mean, even go with the job postings, they ask whether you know about containers and Docker and everything. So that's why we are here. All right. So just this is kind of a default thing. You may have already know this, but since this is a get started guide, I thought we have this. So virtual machines versus containers. So what is the difference? On the left hand side, you can see the virtual machines. On the right hand side, you can see the containers. So I'll talk about virtual machines. So here you can see the infrastructure layer and the host operating system. And then on top of that, you have hypervisor. And on top of that, you have each different machine, each having a guest OS. And on top of that, binaries and libraries and the apps that they are running. And one thing to note here is, I mean, this type 2 virtualization, because there are two types, right? Type 1 virtualization and type 2 virtualization. I added type 2 because I guess that you are like more familiar with it. You know, tools like VirtualBox, VMware, they kind of, to provide virtualization, they use the underneath host operating system. And whereas type 1 is just straightly on top of infrastructure or hardware layer, like Hyper-V is an example, right? So anyway, the idea, whether you use type 1 or type 2, the idea of the virtualization is where you have a guest operating system and you get the isolation in machine level, right? And then on the right hand side, you can see the containers where you have infrastructure, host operating system, and the container engine. And then on top of that, you have these binaries and libraries, apps, running apps required to run those binaries and libraries. And here you can see that every container is like, you know, using the same operating system. And I mean, we will talk about containers in detail. So my main focus was to give you a like understanding about VMs versus containers. So in summary, if we want to like tell it in a single line, right? Virtual machines are, you know, isolation of machines, whereas containers are just isolation of process. So how they do that isolation in containers, let's talk about in the upcoming slides. I mean, also, again, you need to understand these two are like, no, I mean, definitely has advantages and disadvantages, but don't think about these as competing technologies. I mean, based on the, you know, use case, you can use these in, I mean, hand in hand based on the scenario to make sure that your systems are running well, right? All right. So then we are going to talk about like what are containers and what problems does it solve? What is the major problem, right? So in the, you know, this is a term which we normally use metrics from help. So as you can see here on this matrix, you can see on the, if we take this as y-axis and the x-axis, on the y-axis, you have different types of like applications, right? So you have static websites, web front-end, background workers. Then you have databases for users, analytics databases, then queue processors, likewise, different types of applications, right? On the x-axis, you can see, I mean, different types of environments that these applications should, I mean, are running. I mean, it can be a desktop, test QA cluster, production cluster, even edge devices. I mean, IoT, Raspberry Pi, likewise, data center, cloud, different environments, right? So metrics of hell means it's the like the challenge of packaging these applications regardless of any languages, frameworks, or like dependencies, so that it can be running on any cloud regardless of the operating system, hardware, infrastructure. I mean, you get the point, right? So for each of these applications, to make them running in each of these environment, you have to create a dedicated solution for each of these, right? So what containers does is, it comes as a single technology where you no longer requires to think about that complexity. You package your application in whatever the framework language you use, you package it as a container, and if that container can be running, containers are supported within, the given environments, you just have to run the container, right? So containers actually reduce this complexity. One note here, we still haven't, I mean, we still didn't come into the Docker thing. We are still talking about containers, right? Okay, so in summary, what is a container, right? So container is actually, just an isolated process running on the host machine, and it's a restricted process, right? So this, I will talk about this isolation. So isolation of containers and processes, and limiting what resources it can access, because containers actually, though it runs as a process, it's not similar to other processes that within your, within your computer that it runs. Is not similar to other processes because it provides this isolation, whereas it cannot see the or access other processes, right? So how does it do that? How what are the features which enables that, right? So it is done using two main features in the Linux kernel level. So those are called namespaces and C groups, right? So we'll talk about those in more detail in the upcoming slide. And the container will actually share an operating system where appropriate, and binaries and libraries, and limited to what resources it can access, right? So again, that isolation, we will talk about that. And it exists, it exists when the process stops, right? So if we can, containers are like, next once in a decade shift in IT infrastructure and process, and we are right in the middle of it. Actually, we use containers, more useful in, app modernization efforts and microservices. Those architectural things are coming in now. That's why containers are like more popular, right? The way, and also on top of that, solving that matrix of a health problem, they kind of offer more speed, lightweight, and portability, right? So these are kind of advantages of containers. Okay, so yeah, then now we will go into like what is Docker, and we will also talk about those how isolation and everything, those namespaces, C groups, concepts, when we are talking about the internals of Docker. Yeah, so in this question, what is Docker in 2021, and even from the beginning, Docker means like a lot of things, right? Docker as a company, Docker as a product, right? Docker as a platform, Docker as a CLI tool, Docker as a computer program. We saw this confusion because recently around, this is not related, but I just want to talk to you about this confusion with the terms, because recently Kubernetes said they are removing the support for, Docker shim actually. And then people were like, oh, our rollout Docker won't be working with Kubernetes. There wasn't anything like that. They were only removing the Docker shim part. So we can take it as another session, but if you want, you can read about it. But anyway, it was the confusion with the terms, because people actually, when even for containers, even when I was starting, it was like confusing because people for containers, they were when you say containers, everyone is saying, oh yeah, Docker. When then there's Docker as company, and you can have Docker as a product, and they have like Docker as a platform, then the CLI tool, everything, right? So everyone using that term. So for this slide, so what we are we are talking about is Docker as a platform. So just to give a brief idea about the Docker as company, they started this as an open source project, right? By a company called .NET Cloud. And then, within a year, everything like became really popular, and, they closed that thing and started the company called Docker, right? So in this session, we'll be mainly talking about Docker as a platform. So just to clear things out. And all right, so yeah, what is Docker? So Docker provides the ability to like package and run applications within a loosely isolated environment, which is a container, right? Simply, it's a container engine, right? So I mean, it provides this great user experience for developers to interact with containers. Actually, when we are going for the upcoming slides, you will see Docker is actually using the internal those Linux kernel features, that namespaces, C groups, then Linux containers, all those. But on top of that, what it has done was it has provided this great user experience and abstracted, I mean, uh, close those all difficulty to understand and everything, and created this great way for developers to use these containers and the features of those, right? And so what Docker does is it provides this tooling and platform actually to manage life cycle of your containers, right? On top of allowing you to run your apps as containers, they allow you to develop your apps and supporting components using containers, and then like distribute and test your apps as a container, right? And also the ability to like deploy your app as a container or just as an orchestrated service in whatever environment which supports Docker installation. Orchestration service means where you run like multiple containers within multiple hosts, right? And it shares the same OS kernel, and it works on all major Linux distributions, and containers native to Windows Server as well. Okay. Yeah, so this underlying technology in Docker, this is where we are going to talk about these namespaces and C groups underneath Linux kernel features which supports this container thing. So actually there's a thing called Linux containers. So what Docker does is it's an extension of Linux containers capabilities, and they have packaged it and provided it in a way which is more developer friendly, as we have spoken earlier. And it was developed in Go language and utilizes Linux containers, feature namespaces, C groups, and the Linux kernels itself, right? So Docker uses these namespaces to provide as like an isolated workspace called a container. So each aspect of a container runs in a separate namespace, and its access is limited to that namespace. So that's how they are providing this isolation. And actually the job of the C group is to, C groups allow the, underneath host CPU to actually better, partition memory allocation into these namespaces, right? So that's how they manage it internally. But what Docker has done is, abstracted all those complexity underneath and provided us with a great experience tool. Okay, so hope you, get the, underneath what is happening and what are the things which are Docker actually using and what's actually Docker, right? So yeah, just to showcase the, that the matrix of hell, the same thing you can see, we can package and all the our applications, and as long as all our environments are supporting Docker, we don't care about what is the application, as long as it's you have built and created a Docker image, you can run them on any environment which supports Docker. All right. So yeah, so we will go into like, basic Docker commands. So this is, Docker CLI structure, which has two versions, the old version and the new version. And the old version is still expected. It works as expected, whereas it has Docker, then the command and the options, and the new version has the Docker command, then sub command and the options. So if you take as a simple example, I have added few, commands here. Pull in a Docker image, you normally run Docker pull image, and then, run in a Docker container, you just give the options, and then you give the name for the container and then the image, and then stop in the container, Docker stop, right? You can either give the name or the container ID. Let's see this in general when we are in the, in the demo session. So then we have the container top command, which allows you to see process process list for that given container. And then, the container inspect command, it shows all the configurations of the container. And then, Docker container stats kind of show overall performance statistics of all containers. And even you can kind of like get in a shell inside the containers and, access what is happening inside the container. And then, listing, removing containers and images. So these are like general commands that we normally use when we are like, managing and working with Docker. So this is, of course, you won't kind of like think about this. I should always ensure that I always remember this, but rather than that, when you are using Docker, as time goes on and you are using these commands for different scenarios, it just happens to remember it, right? So don't kind of think you have to remember this by heart. As you use this, because since I on the chat when we are starting, a lot of people said like, they are beginners on this. As you use Docker, you tend to, get familiar with these commands and their use cases, right? I just wanted to point out the basic commands. All right, so now let's kind of deep dive into the internals of Docker, how things are working in internal. We talked about these namespaces and everything, which is going, we are going again, kind of going one step further internal to understand what's actually happening within Docker. All right, so we'll talk about the Docker architecture basically as the first step. So if I got this image from the Docker documentation. So you can see like three main components here, right? You have the client, Docker host, and the registry, right? So, as you can see this, you can tell that Docker uses client-server architecture. Docker client talks to the Docker daemon, which is, Docker daemon can be running on the same, the same host or the same system, whereas you install Docker on your computer, it's running on the same host. But even you can connect with, a remote Docker host as well. And, this client and Docker daemon, the communication is done via a REST API, right? So that's, our Unix socket or via a network connection. Then you have this Docker daemon component, this one, right? So Docker daemon is actually, we normally say it as Docker D, right? So what it does is the job is to, listen to the API requests of Docker client and then manage Docker objects, right? So Docker objects means anything which Docker manages, like Docker images, Docker containers, volumes, networks, likewise. It can communicate with other daemons as well to manage services, and that's actually what happens in Docker Swarm, right? So we'll be slightly talking about Docker Swarm. I will just, just for the record here, it can also communicate with other daemons. And then you have the Docker client, right? Again, we tell the Docker client as Docker. Again, you can see this Docker term is being used in different places, but means different things, right? So this Docker client is like, the primary way of users interacting with Docker, right? So actually as a CLI tool, underneath the Docker client, it actually uses the Docker API, right? Then we have the Docker registry. Okay, so the registry's job is to like store Docker images. Think of it like as, you can think of it as a place like where you store your code, like version controlling system. Likewise, this is a registry where you kind of store all your Docker images, right? So by default, there is a product called Docker Hub, which is again managed by Docker company. And by default, when you pull or push, and Docker image, it connects to Docker Hub, right? But you can even create your own registry, right? You can host your own registry, or there are like many other third-party solutions where you can use it as a registry, right? So, I mean, what it does is it actually stores these images, and if the images are actually not within this local cache within the Docker host, what Docker daemon actually does is it talks to the registry and obtain this, pulls these images from the Docker registry. All right. So before we go again, I mean, into the actual Docker objects and what's happening inside, just to showcase what happens, I mean, in an high level, what happens when you run a container. Contain in the sense, I mean, when you run a Docker image. So what happens is you run Docker, then you provide an, I mean, //p, then you expose the port. I mean, internally, we will talk about this in detail, but Docker has its own internal virtual private network for host to actually communicate with that internal thing. You have to expose that port. So what it does is it exports port 80 within the host to the Docker's internal networks port 80, and this container will be running. I mean, this is the image, and we haven't provided any name for this. So Docker will create its own name randomly, and it actually runs this, this image, right? So as the first step, what it does is it looks for that particular image locally in the image cache. And if it is not found, as I explained before, it pulls it from the configured registry, right? It can be like, Docker Hub or any configured registry image repository, and downloads the latest version by default, because we haven't specified a tag here as the latest, right? So again, this is a slide people tend to, slightly confuse this. Don't think like Docker will, automatically bring the latest components of this image for you when they use this latest tag, right? So what happens here is it's the responsibility of the party who creates the image to always ensure that you tag the the latest code or anything which relates to your image. You tag it as the latest tag, so that when people actually pull that image, the latest tag will bring the most updated versions, right? So actually, that's a thing which, as an image publisher, or if you are creating image, you should always ensure that you are like updating your most updated version will be available and tagging it with the latest tag, right? So don't think like Docker has the capability to find your latest pull and it will bring out that when you pull the image. No, it's actually used as a term, latest. So as the image publisher, if I am publishing the image or you are publishing the image, it's our responsibility to ensure that we always our most updated version we are pushing and tagging the image and pushing it with the latest tag. So when people use this as the directly, when they use the image name without the tag or with the latest tag, they will get the latest version of our app, right? It just comes down to tagging, right? So hope that clears if you have had any confusions. And then as a second step, it creates a new container based on that image and prepares to start. And then what Docker does is Docker allocates read-write file system to the container as its final layer. This is the step which allows you to modify files and directories within its local file system. So this step, read-write file system layers, if you don't understand, just bear with me. We will be talking about those in detail. And as the fourth step, what it does is it gives it a virtual IP on a private network inside the Docker engine. We'll also talk about the Docker networks. And then as the fifth step, what it does is it opens up port 80 on the host and forward the traffic from host port 80 to host containers port 80. and then starts the container by using the CMD or the command in the image Docker file, right? So these are the basic steps which are happening when you run a container. So let's further understand what's happening inside. So if we take like Docker objects, Docker object means anything which is managed by Docker. So Docker images, I guess, I believe I've told you this earlier, images, containers, volumes, network, etc. I mean, a Docker image means like it's a read-only template with instructions, right? It's like an instruction set for your Docker container, right? So you can kind of create your own image. Okay, you can write your own Docker file and you can create your own image, or you can create, use an image published in the Docker Hub, registry, which was published by others, right? So Docker file can be used to define steps required to create and run the image. So each instruction in Docker file creates a layer in the image, right? So only those layers which changes each time are rebuilt when you are building that image again. This is what makes these, Docker images so lightweight, small, and fast. So again, if you don't understand these layers and everything we'll talk about, just bear with me for the moment. So, when you are writing a Docker file, normally, if you have written Docker files, you can, understand as the initial step, we always put that from tag and gives that base image, and then we have different lines that we put like add, copy, run, these kind of things where each of these commands will you put in the Docker file will actually create a layer, right? Only those layers which changes each time this image is built are the ones which will be rebuilt. Otherwise, it will be using that from the previous layers, right? So we'll talk about that again. And also, then we are coming to the other one, Docker containers. So Docker container means a runnable instance of an image, right? You can create, start, stop, move, or delete a container using Docker API or CLI. And even you can connect your Docker container to one or more networks, attach storage to it. You can even create a new image based on its current status. We are going to talk about this. There's a concept called Docker commit, where you can, actually turn an existing container to an image, right? Let's talk about that in the upcoming slides. And a container is, always defined by the image as well as configuration options provided to it when you create or start it. If you can recall, we have provided for that command docker run //p, and you given the image name. So it's always defined by the the Docker file, of the image, as well as configurations you provide it when you are running it in the command itself, right? And also one thing to note is that when a container is removed, it is completely removed, any data associated with it will be completely deleted unless those are not stored in a persistent storage. And Docker provides us with a way to handle this thing. So we'll talk about in those, how Docker provides us that feature in the next slide. Okay, so before going into that, in the previous slide, I have mentioned, just bear with me because we are talking about this layer concept and what's actually happening. And I told you image is, this read only layer, right? Then I talked that container was this runnable instance of an image. So let's we are gonna go more deeply and understand, what we were talking there, right? So under this, first thing we want to understand is this, Docker file system. So normally if you take a, Linux or the Unix like system, everything is like based on a file system, right? File system hierarchy. Everything is as a file, or it has this directory structure. So mainly if you take, you know, Linux or Unix like system, you have two components file system, right? The main one, two are these, bootfs and the rootfs, right? So bootfs is where it contains the bootloader and the kernel, right? So user never touches this, or the user processes are running on this rootfs, and it kind of includes this typical directory structure we associate with Unix like operating systems. If you are used Linux operating system, you are aware of this directory structure. You should be, right? You have this, /etc/bin/opt/tmp, likewise. That's in rootfs, right? So, in traditional Linux boot, what happens is kernel first mounts the rootfs as a read-only thing, and then checks its integrity, and then switches the rootfs volume to read-write mode, right? So again, use the boot, and then kernel mounts the rootfs, and then integrity is checked, and then switch that to a read-write mode, right? So what Docker does is, Docker mounts the rootfs, and instead of like changing the file system to read-write mode as it happens in traditional Linux boot, what it does is it takes the advantage of a feature called union mount service, right? To add a read-write file system or the read-only file system, right? So what happens is when an image is downloaded, image is pulled, actually that image is considered as a read-only file system, right? And then what Docker does is, Docker uses that same traditional Linux feature, and rather than, instead of changing the file system in traditional Linux boot, we were like, switching the rootfs to read-write mode. But rather than doing that, what Docker does is it actually using union mounts, it adds a layer on top of the read-only thing, which is Docker image, as a read-write file system. So that's the actually a container on top of the actual image. So on the next slide we have some images, so it will be like more clear to you. In Docker terminology, before that I want to explain you this union mounts, right? So union mount, or UFS, is actually a union file system, is a feature where it allows you to like combine multiple directories into like a single thing, and you once you use that, it to the outside it appears as a like combined single thing, right? So we talked about, in Linux, all these are like files. So what UFS allows is you combine all those and you can see those as together. Actually, the container and the image below the, you have the container on top of that layers, and on the below layers you have the image, right? So in Docker terminology, a read-only layer is called an image, right? So an image never changes and fixed. So if you do Docker pull, you actually pull that image, that all those layers, right? So each image depend on one or more image, which creates a layer beneath it, right? So again, we will explain this with an image in the image. It means a graphical image in the next slide. So where each in images, like, you have different layers on top of each other, like a stack data structure, right? So you have different layers. So each layer on top is always, depends on the layer below of that, right? So the lower image is the parent of the upper image, right? So each of these layers are synonymously named as like images as well, right? So any image without a parent is called the base image, right? If you are been writing Docker files, the first thing you adds me from like Nginx or from Ubuntu, that's act as a base image. So when you actually run a container, what Docker does is, this is the what's happening internally, right? We look what happens, I mean, in high level. Internally, what Docker does is it fetches the image and its parent image. It starts with the top layer and it then goes to and fetches its parent's image. And then it repeats this process until it reaches the final layer, which consists of the base image. And then it uses this union file system to add the read-write layer on top of this, right? So that read-write layer plus the information about the parent image and some additional information like unique ID, network configuration, resource limits, all together is known as a container, actually Docker container, right? So yeah, this is the image, graphical image I was referring to. So as you can see, this writable part is a container. But normally what happens is these are different layers or images of I mean, in an image. These are only read-only components, whereas when you run a container, what happens is it creates a read-write layer on top of that thing, and it makes everything appears as a combined thing using that union file system or union mounts that we were talking. And this refers, each layer refers to the layer below it, which is the parent image. So if we like, I mean, directly run that Nginx command, docker run Nginx. So what it does is it checks whether the image is there. Otherwise, it pulls these layers. Initially, it starts with this layer, and then identifies whether the parent of it, and the process goes on until it reaches the base image, right? So, and then when the container is running, it adds another layer on top of all these read-only layers, which consist of the Docker image, and create the container. And everything looks as a single component with union file system. Again, on this side, you can see this has only one base image, right? So that's why it's a base image. And these at Emacs, at Apache, all those are like, different lines you put in Docker file, right? Actually, if you want to, like, I mean, I invite you to read the Docker documentation. They have a great documentation, and on that documentation they talk about this great best practices for writing Docker files. This actually they talk about this layering thing and how you should write Docker files in a way you can optimize this layered concept, right? So based on the previous slide and this slide, I hope you can now, like, I mean, really understand what is the difference between an Docker image and a container and what's actually happening inside. So I mean, the only difference between the image versus container is this top read-write layer, where for an image as a whole, this would be like a read-only, and when the container is running, it's like, read-write layer. And when the container is completely removed, this read-write layer is removed, right? So since each container has its own read-write layer, this is what allows us to use the same image to create multiple containers, right? Because the image, Docker image, of course, is consisting of multiple layers, and those are only read-only. The read-write layer is only the container. So this is what allows us to use the same image and create multiple containers out of that. Okay, further talking, I mean, further going into these containers, actually containers have like two states. I mean, when it's actually, I mean, the other state is you completely remove that. Other than that, two states, either it's running or exited. So when a container is exited, the state of the file system and its values are saved, right? So then what you can do is you can like start the container, restart it. So when you are restarting a container which was at exit state, not a container which was removed, right, which was at exit state, I mean, you can preserve its file system as it was when the container was stopped, right? I mean, but the memory state of the container is not preserved at all. And I mean, also another thing is when you actually containers are a thing which is, we normally say they are immutable and ephemeral. I mean, they have very short lifespan and they don't change, right, often, because when you build a container, you ensures that container stays like that, right? You normally, in normal circumstances, you normally don't change the internal file system, but if that container is at exit state and if you have changed the file system, internal container file system, when the container is restarted again, a stopped one, exited one, then that file system is available. And mean, you can even remove the container permanently. And also a container can be, as if you can recall, we were talking about this, we can promote an Docker container directly into a Docker image using the command called docker commit, right? So once a container is committed as an image, you can actually use that, you know, create other images on top of it. This is actually the command for that, docker commit. I mean, read the documentation. It has great scenarios and examples and walkthroughs how to do this. All right, again, continuing our discussion on this union file system and Docker's internal strategies. So this, again, Docker, this graphic explains you the thing. It uses the Ubuntu 15.04 image, and you know, it has different layers. These are like read-only layers. This is the Docker image. And when you run a container, it creates a read-write layer on top of this, right? So to actually provide the, the efficiency of Docker, by minimizing input, output, and, you know, and the size of each subsequent layers, what they use a strategy called copy on write, right? So what happens is, if a file or directory exists in a lower layer, imagine this layer, right? And another layer, including the read-write layer, the container layer, or this layer wants to access that, it just uses the existing file. It refers to this, right? In a scenario where the first time another layer needs to modify the file, file modification can be done when you are building the actual image or within the container itself, right? Then what happens is that file which needs to be changed, that layer, that file will be copied into the layer which actually wants to change it. Either it's within the image or it's within the read-write layer. So that that copy thing happens only when you requires a write thing, right? So that's how they actually minimize the input output and also reduce the size of the subsequent layers, right? Subsequent means layers on top of each other, so layers one after the other. So that's how they reduce the size of that. Yeah, so we talked about this, but again, Docker image creation and storage. You can create an image using Docker file or just by committing a container's changes back to an image, as we spoke earlier. And once you create an image, it will be stored in the Docker host local image cache. So if you want to like move images in and out of the local image cache, you have to, import export is as a tarball, but the most upfront and basic way is to push and pull that image to a remote image registry, Docker Hub, as an example. Okay, so continuing, that was like really kind of deep discussion into Docker containers and images and what's actually happening inside. So continuing that thing, we will come into the thing where we started Docker objects. We were talking about images and containers, and we were going through the internals of it. Now again to that main subtopic we started, Docker objects, Docker networks, right? So Docker network is again a thing which is managed by Docker. So each container is connected to a private virtual network called bridge when you run a container in Docker. So if you do Docker network ls, it will actually show the default networks it has, right? So that bridge type is default network it has, and each virtual network routes through the, I mean, it has like, you know, net firewall, network address translator firewall, and each virtual network route through the net firewall on the host IP. I mean, it routes to the net firewall. You have the host network, net firewall, and within that you have the Docker network, right? So all the containers on a virtual network can talk to each other without exposing ports, right? I mean, containers deployed within the virtual network of Docker, they can talk to each other without exposing ports. Exposing ports only comes when actually you want to access it from the host side, right? So the best practice is to kind of create a new virtual network for each app when you are basically running multiple containers. So Docker actually enables you to create new virtual networks, right? Attach container to more than one virtual network, and you can completely skip the virtual network and directly use the host IP. You can pass this option --net equal host. So it will completely remove deploying your container on the virtual network, and it will deploy it on your host network, right? And you can also, I mean, you can use different Docker network drivers to gain new abilities. So Docker Engine provides this support for different network drivers. By default, it has, you know, bridge overlay and McAfee and etc., right? I mean, different network drivers. You can, to understand more, you can read the documentation, and even you can write your own network driver, right? By default, it provides this bridge network. It's a default one. Containers are by default deployed in this network, bridge network, and it is limited to, like, you know, single host running Docker Engine. Overlay network is another type of network where, you know, it can include like multiple hosts, right? Again, it's used when you are running your Docker containers in like Docker Swarm, right? We'll talk about it. And then Docker also has this the domain name system, I mean DNS solution as well, domain name service. So Docker daemon has a built-in DNS. Actually, you know, it uses the container name as the equivalent host name of the container, right? All right, so these are some you know, images I took from the Docker documentation. So you can see here, this is the host network, the net. Then we have this you know, this Docker 0 is the default net bridge network. This my bridge is you can create your own bridge networks as well. You can see the DB applet container is running on my bridge thing, and the web is running on the default bridge thing. And again, this is where, you know, you can use the like you know, same bridge network. It like allows you to attach as many you can attach the single network to many containers as you want, right? Even you can like attach an already running container, just to show you kind of the capabilities and features we talked earlier under Docker network. Okay, so the persistent data. So I mean, we talked about these Docker containers, right? I mean, Docker containers, when the container is completely removed, all data associated with that will be gone, right? So I mean, you have scenarios where you want to allow containers to run like, you know, databases or like unique data stores, right? So to do that, to persist data, Docker enables using two ways, right? Those are Docker volumes and bind mounts. Docker volumes is actually a thing which Docker manages. So now you know this UFS, Union File System, and where it is used and why it is used. So when volumes are created, what Docker does is it creates it outside that union file system, because UFS is the technology which allows to, like, combine that containers read only and images read only and containers read write as single combined one. So when the container is removed, that is you know relationship is removed in. So as volumes need to have persistent data, so what it does is Docker creates these volumes and manage those in a location outside of the containers union file system, right? And the other option is bind mounts. It's actually, those are not controlled by Docker. It is actually, you are linking the path of host to a containers path, right? Let's actually look into those when we are in the demo session. Yeah, so then this, I won't talk about this Docker Compose, right? Up to now, we have been talking about the Docker client, normal Docker client, where you interact with a single container at a time. So what Docker Compose is another Docker client which lets you to work with apps consisting of set of containers, right? I mean, this saves the Docker container run settings in an easy to read file, where even it can be committed to version controlling systems like Git, Bitbucket, right? And you can use this to create one-line development environments, right? The idea here is, earlier we have been, running containers like, Docker run Nginx, right? Docker run Ubuntu. Those are like one containers. But in most cases, to create development environments, likewise, you have multiple containers, like, as you know, the front end and the database likewise. So you can actually, with Docker Compose, you can create that as in single YAML file and add all the images, containers, networks, volumes in YAML format. And Docker on top of that provide a CLI tool called Docker Compose, used to kind of automate and manage those YAML files, right? And again, I have been telling that about Docker Swarm. So I won't be covering Docker Swarm in this session, because I thought it would like drag the session, as well as it is under container orchestration topic, plus also the, we using usage of Docker Swarm is like, we haven't seen like many adoption on usage of Docker Swarm. So simply what Docker Swarm does is, it's a container orchestration solution. Orchestration solution means you run multiple containers within like multiple hosts, right? You to manage it's like bit similar to Kubernetes, but the naming conventions underneath how things work, the complexity is like totally different. If you want, you can try that out. That thing is there, but you don't see, since the adoption is very low, you don't see as a service solution for Docker Swarm. But you can install and add multiple hosts and work with that. It's kind of beginner friendly, right? So I won't cover that in detail. I won't cover that in the demo section as well. Yeah, so this one, Docker build kit and buildx. This is the final part before we go into the demo session. But this one is kind of a more like advanced feature, which is like introduced around Docker 19.03. It's kind of not like, really new. It has been there for some times, but I thought this has some cool sets of features. So I thought let's, cover this up because, maybe you would find it, interesting. So actually this build kit, what build kit does is, it enables higher performance Docker builds, and also provides this caching possibility to decrease build times and increase productivity. Actually, they will do this for free. Actually, it's coming under Moby project. So Moby project is actually managed by Docker. It's an open framework, and it has several projects which specialize, container systems without like, reinventing the wheel, use the existing same features, and they are building like great new features on top of that. So you can, I mean, I will share these slides as well, so you can refer these links. And what actually it does is, you have this standard Docker build command, right? So when you are writing a Docker file and you want to build that Docker file and create image out of that, you use the command docker build, right? But in docker build, I mean, when in docker build, it builds the normal docker build, it builds each line, or I mean the layer. Now you know the thing in the docker file as one layer at a time. And I means the build is done serially, right? One layer at a time. But with build kit enables, what happens is it allows you to, I mean, build these lines parallelly, right? Creating a parallel build processing, and it actually provides you better performance and faster build times, right? So if you, I mean, if you are a person who has been using, Docker build in CI/CD, and you think, okay, our build times are a bit high because, sometimes when it comes to some images, there are a lot of things to do and the build times are high, you can use this feature. It's available. And also it also enables you to use like a cache and storing cache in the, I mean, the remote container repositories like Docker Hub, right? So earlier we don't get this because the image cache is within the, image, the local system itself. You can actually with this store the image cache in remote container repositories like Docker Hub for better build performance. As I mean, we don't have to rebuild every layer of an image. And also you can enable, as I told you before, you can enable build kit in places where you use Docker build, including, continuous integration, continuous deployment, delivery pipelines to like reduce build times, right? So it's a feature you can, I mean, experiment and identify. And on top of that, I want to talk about this BuildX, because BuildX is actually I mean, I'm sorry, build kit was there, but BuildX is actually introduced with Docker 19.03 version, I guess. So BuildX is actually CLI plugin, command line interface plugin, that actually extends the Docker command with full support of the features provided by build kit plus additional features. Actually, if you now install Docker desktop versions or Docker Linux packages, I mean, you can even download it as a source from GitHub, right? This BuildX is available. It has this build kit features, the features we talked earlier, plus some additional features. The first thing is, familiar user interface from Docker build, right? And then, this full build kit capabilities with container driver, and then multiple build instance support where you can use like, multiple instances for building. You can add that support as well. And then this is the feature I want to talk about, this multi-node builds for cross-platform images, right? This cross-platform means, I mean, before version 1903, building like multi-platform images required you to like manually create underneath manifest files and build images separately, right? With BuildX, all these are included and allows you to create multi-platform image. So if you are thinking what are multi-platform images, so I mean, it comes in handy if you are image publisher and you want your image to be like supporting for multiple architectures, like for you want to run your application on like ARM64 and I supported things like EC2 A1 instances, or I mean, you want to run your images support, you support for your images to be running on like Raspberry Pi, right? You can create this multi architecture images, right? I mean, Docker had this capability, but before this BuildX, I mean, Docker, you had to write this manifest file, right? Manifest file means a source file which acts as a source file where it contains, okay, for this platform, this is the image which it refers, and for this platform, this is the image it refers. So likewise, it contains all those details. So that is from a site where you create multi-platform images. So this comes in handy because actually with BuildX, those creation of those manifest files, everything is taken care of. You just have to provide the platforms, you have to build the image and run the command. And also the other thing is this bake command. You can understand because in Docker Compose, I mentioned you can write, you can specify different containers. Different containers, multiple containers. This bake command actually is similar to Docker Compose build. It allows you to build those containers rather than serially. It allows you to create those multiple Docker Compose containers parallel, right? So that's one option as well. So the most interesting part I found was this cross-platform images. So you may as a person who is using Docker, if you have installed Docker on Raspberry Pi and you want to run a Docker container there by pulling a Docker image. So what actually in the backend, what happens is Docker actually, when it goes to the registry, it looks into what is the architecture that you are coming from. So it identifies you are coming from, all right, the Raspberry Pi's architecture, like Linux ARM v7 or v6, and then it actually goes to the manifest file that I was previously mentioning, and it identifies, okay, this is coming from this architecture, so I should send this Docker image for that thing, right? So that's how they use the manifest file. So this is mostly important for people who actually build multi-platform images. If you are into that type, I believe this feature is a great one for you. And I have added a demo from this as well, because it's pretty new and it has been there, but it's not a feature we normally talk about when it comes to this get started sessions. And this is a great article I found. This if you, on the references sections, I have added these references so you can see the difference, right? Classic Docker builder versus build kit plus BuildX. So if a dependency change, of course the same, but for code changes, you can see like 50% reduction, and then no change building time still, because of that cache capability build kit allows you. It has great performance optimization. All these are kind of, this final part are kind of advanced features. So though it's advanced, it's great features if you want to try this out. And even if you have been using Docker, you can actually use these features to optimize your existing ones as well. Yeah, we'll do a simple demo on that as well. We create a multi architecture image out of the thing. All right, now we will get into the demo section. Demos we use really basic versions just to showcase the capabilities, right? So if you want to really deeply understand these concepts, the best thing is to try this out, read the documentation, right? When you find a new platform or you are starting to learn a new platform or technology, we all do, right? At some point, we all had to start there. And, in this tech field, platforms and technologies are rapidly changing. So you have to always be in that hustle, learning, reading the documentation, try new things. That's the best way to learn, right? So I invite you to read documentation, but in the demo sections, I will try to give you the basic understanding of this thing. So I will exit from this slide a bit. I will, yeah, just give me a moment. I'll put in the terminal as well. Yeah, hope you can see the terminal. Can you see my terminal clearly?
Ravindu, can we make it a little bit large in the text?
Yeah.
Yeah, now it is
Okay.
clear, I think.
Great. Yeah. Thanks, Dhanush. All right. So, initially, the first one is first demo part is this. We are going to run and stop and remove just a simple Nginx container using Docker CLI. For that, before going there, I will kind of like, take you to Docker Hub. And so this is actually the Docker Hub, right? So this is the Nginx image that we are going to build. So, quick reference, you have here this latest one, tagged as the latest version. And if you click on this, you can see the, Docker file thing, and this is the final command when the container is running. So all these are like the Docker file. This is a Docker file as the base image. It's using the Debian Buster Slim one. So other than that, you can see here, it supports ARM 8664, right? Different, versions. And want to show you this one. Yeah, you can see this, it supports multiple architectures, right? So all these details is coming from that manifest file I've been talking. So I will build our own image as well and show you this. These are different layers, right? These image layers, we talked about this. So now going to Docker Hub and looking at this, you now should understand what are image layers and what it actually means, right? So you can see all these components. All right, so yeah, let me command. I've added these commands because let's see. Yeah. So here I will explain the command. It just runs interactively, normal, standard input. And this --rm option means, once the container is stopped, it will automatically remove that. It will not go into the exited state without this flag. If you stop the container, it will directly go into the exit state. But with --rm, it won't. -d means detached or daemon mode. That means it will run in background. /p 8080 means we are using the host port 8080 and routing the traffic for the containers 81 because internally it runs on the Docker networks 80 port, and we are also given a name, and then we are the Nginx one. We are not using tag, so that means by default it's using the latest one. All right, so we'll run. So it says unable to find the image Nginx latest locally. So it's like pulling these layers. This is the process we talked about. It first finds the layer, then goes to the parent layer, then again, and does this until it goes to that, base image, right? It downloaded and it just now running the containers. So if we do a docker psa, you can see the container is running. Host port 8080 is now routing traffic to 80. So if we so host, you can see there it has deployed Nginx, right? The basic thing. So what I will do is I will run stop. Yeah. No, not because container stop. We'll give the name because we have given it a name, and it says, we'll stop the container. Yeah. Now if you run Docker, you say you won't see any containers running, and If we reload this, this is gone, right? All right. Okay, so that was the first demo. I'll do is now the second one is actually we are like building, pushing and building, packaging, pushing and running this a simple node application with Docker, right? So I have actually shamelessly cloned some great demo repositories from GitHub. So I believe someone else is sharing the screen. Yeah. Thanks. Share the screen again. All right. Can you see my screen? Yeah. Great. Thanks. So what we'll do is we'll, a simple node app, just node demo. Yeah. So it contains the Docker file, app.js, config, package, and some tests. If we like go to Docker file, you can see just a simple one, node Alpine base image, and it uses the work directory. And this copy command copies all the current context into this worker directory, and on top of after that it runs npm install and then the command that the container is going to start with. So each this run copy, this one will create like a layer, right? Layer of within this Docker image that we are going to build for this. Let's exit out of this. So other things is simple Node.js. So I won't go, all those node files. Let's just initially what we'll do is let's just build this. So what I'm going to do is I'm saying Docker build -t, t means stack. So I'm going to say is Docker demo. And this dot means, this Docker file is in this current directory, current context. So I will hit enter. So what you can see is it's actually building the Docker image now. And you can see these different layers are being built. This is the final layer, npm install. All right. Then what I'll do is I will just run this image we just built. We'll run this interactively, same remove thing, and with the detached mode, we'll give it a name. We'll say node, and we're going to run node demo. Before that, I will show you the images. So images which are built. Yeah, you can see this Nginx one we pulled this node demo, and it since I haven't given a tag, it created latest by default, right? So it's there. So what we'll do is we'll run this without exposing the port, right? So then what will actually happens is you won't without, if you haven't exposed the port, you won't able to access this, right? So by default this app is running on port 3000. So in order to access this from the host system, you have to like expose the port. So I will just run the command exposing. So in the detached mode, we'll give it a name, say it node, right, on the port. So I want host port 5000 to route traffic to the container port 3000, and the image name is node demo. All right, this looks good. Hit enter. Yeah, it's running. PSA would give that the image is running. And then what we can, we should be able to see this localhost for 5,000. Yeah, our container is running here. And all right, then what we'll do is we'll actually container stop mode to stop that container. So just to show you the app.js, it has FOSS LK, right? So in the config port was 3000, just to show you. And then what we'll do is, as the next step, we'll actually push this to Docker Hub, right? My Docker Hub account. And for that, we need to do Docker login. I already had logged in, so it uses my existing credentials. So now what I will do is I will tag the image before I have to push this for Docker Hub, the repository. For that, I'll use Docker tag command. The image name is node demo. So this is actually my username for Docker Hub. So it is actually, if you are using another Docker registry in front of this, you give the registry's domain. But since we are using the Docker Hub before, I will show you it actually has that Docker Hub's URL there, node demo. All right, so I'm tagging the image node demo as my username / node demo. Okay, yeah. And then what I'll do is I'll do Docker push, right? This image nf94, my username node demo. Yeah, you can see it uses docker.io. This tag is latest. Push refers to repository, new repository, and you can see these layers, right, that we talked about, read-only layers. Now it's pushing that to Docker Hub. All right, so let's go into my Docker Hub profile. And I will actually reload this. Yeah, now you can see this, this image is now added. You can see the operating system ARM64 architecture with this laptop and, latest tech. Yeah, I guess that's worked well. So, we have pushed our image, and if you go into tags and go into latest, you can see, different layers. You can see this add commands take space, run commands has taken some steps. Storage, copy command. You can see those are the ones which are actually creating layers, right, that we talked earlier. All right. Up next. Yeah, so that actually concludes our second demo, which is, let's close this as well, which is actually, the building, pushing and running a simple Node.js app. So up next, our demo is related to Docker Compose. So here, what I will go to, this thing. Mongo. So here, what we do is we have two applications. Just a simple Node.js application, and then on the other side we have a simple database which is using MongoDB and we are running it as a container. And since MongoDB is related with persistent storage, we actually has to use volumes to ensure that when the containers are gone, that data on that database is already there. So I'll simply go through the Docker Compose file. You can see the YAML file. compose. Yeah. So this is version 3.9, the latest one. And you can see this is like, I mean, there are a lot of tags and, ways, capabilities within compose. I mean, if you want to try those all out, read the documentation, try it out. For in this demo things, we are only, going with the most basic version. So it under services, it actually creates two containers node, and it is building, we are building this using the existing Docker file on the same context. And as ports, we say, run this node application on localhost port 80 and, route traffic to port 3000. And here you can see a volume. Actually, this is a bind mount thing. So what happens is, it mounts the contents within this dot slash, that means the current context. This dot slash path is relative to the, compose file, right? And what it does is it actually, now if we take a look at the contents in this path, you can see these are the files. This is the place where Docker compose is there, and these are the files in that location. And what it says is, mount those contents actually to /code folder within the content. And these types of volumes are actually not managed by Docker, right? So then you have the Mongo container, you have the image Mongo, and you expose port, localhost, the host port 2707, default port for Mongo. And then you say, named volume, you add MongoDB's volume is /data/db, named volume to persist data, and then this named volume will be added here, MongoDB, the same name, right? So basically this will create like two containers, one node, one Mongo, and also, a volume which Docker manages outside of the containers union file system. And also another thing I want to point out here is, I'll show that actually, when you run compose, it actually takes care of creating like, a common network between the containers as well, right? So, it takes the working directory's name _ default. Likewise, it creates a network as well. So I will show that as that thing as well. And then each container for a service, unless we haven't defined a network, it will like joins to the default network, and it is like both reachable within the same network, and it is discovered by the host name identical to the container name on that network, right? So what we will do is, we will actually run the command and bring this up. So we'll run docker compose. So if you just type the command, you can, right, it shows you all the command options it has. So we'll run docker compose up. We want to run it in detached mode, and we will give this build as well. So build flag is actually used because if if any change is made to our source files within the node app, it actually tells the compose to rebuild the image for our container node container, right? So, all right, set enter. Yeah, it's actually, since these images are not there, it's actually pulling the images. So you can see different layers are being pulled. So I haven't pre-downloaded these images because I just wanted to show you kind of all the steps involved in this, and the command output as well, just to show you how it brings in those different layers. And now, since the node alpine image was already there, it's actually uses the existing one. and then it's running npm install, and you can see network node mongo docker our compose underscore, that's the working directory underscore default network was created, and you can see a volume is also created, MongoDB, and you can see 2 containers are now running. So if we say docker compose, sorry, docker PSA, you can see 2 containers are running. And also to show you that mounted volume, I will actually shell into that given container. So let me get the container ID. Okay, this is the container ID for the node 1. So the name is node 1 thing. Okay, so what I'll do is docker exec -i -t, and I'll put the container ID I want to shell into, and so I'll say I want to go into ASH because we are using ASH because we are using the Alpine image. If you have been using my normal shell, it would be like bin/sh. So yeah, now we are inside this container. So now we're in that directory. You can see the working app directories there and everything. And if we go one up, you can see this, code folder, right? Now we are actually within this, container, right? So this is the container file system we are actually accessing now. We're actually within the container. So this code thing, you can see it has copied all the files, with relate to Docker Compose location to this and mounted those to the code folder. So yeah, we'll exit from the container. And also I will show you the Docker volume ls. Yeah, these just don't care about these local ones. Those are what Docker creates for the internal purpose, but this is the one which was created by Compose. And I will show the network as well. Yeah, this is like, the bridge default one, the host one, and this is the one which was created by Compose for this thing. And so then what we'll do is we'll access the thing application. It should be this things here. We'll do is docker compose logs -f. Show you the logs. So let's go into localhost. Yeah, this is that it created. So let's add some items. You can see the logs are coming from here, like 16, 18. So all right. Okay, so one more item. Okay, so now what's happening is that actually adds the items to our Mongo thing. So now what I will do is I will bring down this thing, with Docker compose down. I will actually bring down all these containers. So what happens here is when you say Docker compose down, it actually removes all the networks and the containers, right? But one thing it doesn't do is it doesn't remove the volumes that it created, right? So in that case, when we run this command, we won't see any of these containers. But when we bring up this environment, when we rerun Docker compose up and bring this up, we should see all this data persisted because the volume is already there. So to showcase that, I will just do Docker compose down. You can see containers are down, removed, network is removed. So if you do quick Docker ps no net containers ls, you don't see those containers, but you should see the volume still there. So this application, it's not working because obviously we have removed that. So what I'll do is I will now I will run this compose up one, and it's building that for us. Yeah, it created that thing. So if now we rerun, you can see our data is persisted, data is still there. So we remove the containers, so we can continue like adding data. So I mean, if you like want to bring down everything, including the volumes as well, what you can do is compose down and give the /v flag, and it will remove the volumes as well. So yeah, all right. So for this, let's clear this out. Okay, so that's Docker Compose demo. And then the final part is this, build kit part plus buildx demo. I mean, this, as I said, bit of an advanced feature, but again, a great feature. So what we will do is we will create a multi-architecture image for that previous image, that node image that we pushed into Docker Hub, right? So what we'll do is we will go from this and we'll go to node Docker demo. We have already posted this image. So what I'll do is I will actually run this command. You can access this as buildx. I mean, you can, if you can even create an alias for your Docker build to actually use buildx. You can simply create an alias. How to do that is available on documentation. This is the buildx command. You can see different options it has, right? And we are going to talk, look into these image tools as well. So what I'm going to do is I'm going to create a buildx build, and sorry, I don't see the command because of this Zoom thing. Yeah, what I'm going to do is Docker build x, and I'm going to give platforms that I want to build this image. I want this to be running on like Raspberry Pi 1 and 2, whatever. So v7, sorry, yeah, v7, and I want this to be running on Linux v6 as well, right? And I want this to be running on Linux 64, right? And I'm going to tag this as my username, f94 node demo, and I'm going to give it a tag like multi-arc. I mean, this tag can be anything, right? You don't have to give like multi-arc thing just for this case to showcase you. I'm going to do this, and on this current context, and this is a one line but has a lot of things which it does. We can also say just once you build this, just to push this, and this should work, right? Yeah, Docker buildx, not the thing I expected. Oh yeah, I haven't included the build command. So okay, yeah, so what it says is multiple platform pages not currently supported for the Docker drive. So it will if we go into buildx and see, it has this default thing which just uses the Docker driver, and it doesn't provide this multi image support for multiple architecture. And those default one doesn't have that. To as a workaround, what we'll do is we will create a new driver. So what we'll do is build x create Yeah, creating a new driver, and driver type is a Docker container, and we are giving it a name, CK builder likewise. So X create driver. Yeah, it created the driver. So if we now do docker build x ls, you can see it's now using this, right? And up next, what we'll do is we'll run the same image. We should actually let this build x use this one. All right, just to ensure that it's using that driver we created. And yeah, so now we will run this and this should work. So now you just see the this actually underneath uses this Mobi build kit and runs it as a container. So this first step is it is pulling that Mobi build kit environment, and now see how fast it builds these multiple images for multiple architectures. And you can see it, you can see all those images, all those steps are running parallelly, right? Not serially. And what it does is it actually builds like 3 images, and you can obviously see the difference. I mean, the speed it does, because it does all these things parallel. Yeah, it builds everything. And also with our command, it pushes that to our Docker Hub as account as well. And also on top of that, as we talked, it also like sends out all the manifest files as well. So it is like pushing the layers now, exporting the images, and you can see these manifests created. Yeah, now everything is pushed. So what I'll do is I will show you the Docker Hub now. Reload this. Now it should have this multi-architecture thing, and you can see it's supporting ARM and ARM64. And you can see here it's supporting ARM64, V6, V7, right? Yeah. And then what we'll do is we will also use this image tools and command and just see the output of that manifest file. So what it does is it inspects, this image right from the repository. Should take some time. Yeah, you can see this is the manifest file, Docker Hub and the, my thing and the tag, then the manifest for like, this platform. This is the name. This is the reference point for this platform. This is the reference point for this platform. Okay. I guess that concludes the demo session as well. Let me come into, that concludes the demo session. If you have any questions and answers, I saw some on the chat. Okay, there's one question. Can we Docker containerize a node backend with MySQL database? Yeah, obviously you can. Can we run a GUI application in a Docker container? yeah, we did that already. We run simple GUI application with Node, and data inserted into a containerized MySQL database will be lost if the container is the data will be lost if you haven't persisted the data using a volume, right? So that will be the answer for that. If you haven't persisted the data, I guess he asked this question before I was doing the compose demo, but I believe the answer for that question is now obvious because we have showcased that. So other than the questions given on the chat, are there any questions? I mean, on the things we have covered or other things? It seems like there are no any questions. All right. So I believe we a lot of time, and these are the like references. So I mean, I will host share these slides. If you want to reach out to me, I will anyway host upload these 2 slides here. And yeah, thank you very much for sticking with this, and I hope everyone of you has got something or understood something, or just improved your knowledge, anything. So if you want to reach out via LinkedIn, just throw your questions and I will definitely help you out. Yeah, thank you very much for the opportunity for Selkie as well. So and just don't leave this thing, because we have, I mean, the organization team has like some quiz plan, and you can win gifts, obviously. So stick with it, and thank you very much. Have a great week ahead. Have a great evening, right? Thank you very much. So let's see you in a future episode with DevOps and everything, so if possible. Thank you very much.
Thank you very much, Ravindu, for the educational, insightful session on Docker. And everyone surely learned a lot of important things about Docker, and it was a really worthy session, actually. So thank you very much again. And we really appreciate your presence here today as our speaker. Okay, so it's game time. Hope you guys are ready. Okay, here's how it will be. As you can see, the link for the quiz link and the pin number for the game are both mentioned in the Zoom meeting chat. You can enter the game using them both, and you will get 10 questions. All of them will be MCQs, and you get 20 seconds to answer each one of them. And I'd also like to suggest that all of you use the name you use to register for this session as your name in the quiz as well, because that way it will be easy for us to identify the winner so that we can distribute the gifts. So I really hope that you will use the name you used for registering the session. And okay, there's another thing. The questions will not be present in the quiz platform. They will be shown in the screen of this meeting, this call. So you have to shift in between. You have to check the question from the meeting and give your answers in the quiz platform. I hope you guys are clear. Can I get a feedback? Are you clear? Okay. We'll start in a while. And I'd like to remind you guys again, please use the name that you used when you registered for this session, when you participate in the quiz as well. That way it'll be easier for us to identify you guys. And don't forget that you will be able to win gifts. So I hope all of you will participate. If there's anyone who hasn't joined the platform yet, I hope they'll hurry up a little. Okay, I hope you guys are ready now. You'll get 20 seconds each for every question. So let's start. Nikhila, hope you're there. Okay.
You can answer quickly.
Okay, we've got 3 winners. Congratulations, Saluka, Binur Ernest, and Mesha Tivangi. You'll be contacted, and your gifts will find their way to you in due course. Okay. I hope that you guys enjoyed it as well and learned a lot of important stuff on Docker as well. So, congratulations again to the winners, and thank you very much, everyone, for joining us today and staying till the end. And so, until we meet again with another session like this in the near future, good night and stay safe, everyone.